Good morning. Myself Navneet Jain. I am lecturer electrical in electronics department here in Government RC Khitan Polytechnic College, Jaipur. Today I am going to deliver subject circuit analysis for second year electronics student EL 202. Some numericals problems, multiple choice questions. This is part 3. So now I start with first numerical and question. First question is, superposition theorem states that the response in any element is the dash of the responses that can be expected to flow if each source acts independently of other sources. Options are A. Algebraic sum, B. Vector sum, C. Multiplication, D. Subtraction. The correct answer is B. Vector sum. The explanation is here. The superposition theorem is used to analyze AC circuits containing more than one source. Superposition theorem states that the response in any element is the vector sum of the responses that can be expected to flow if each source acts independently of other sources. So, superposition theorem states that the response in any element is the vector sum of the responses that can be expected to flow if each source acts independently of other sources. This is the right answer. Next, a circuit is given here. Determine the current through 2 plus J5 ohm impedance considering 50 angle 0 degree voltage source. The voltage source in this circuit is shown here, 50 angle 0 degree volt, and inductance, resistance, capacitance means impedances, and other voltage source is 20 angle 30 degree ampere. This is current source. So explanation, the options are first A, 6.42 angle 77.47 degree. Option B, 6.42 angle minus 77.47 degree. Option C, 5.42 angle 77.47 degree. D option is 5.42 angle minus 77.47 degree. Answer is D, correct answer. The explanation is here. According to the superposition theorem, the current due to the 50 angle 0 degree source is I1 with the current source 20 angle 30 degree is short circuited. So I1 equal to 50 angle 0 degree divided by 2 plus J4 plus J5 impedances. Okay, this equal to 5.42 upon angle minus 77.47 degree. This is the correct answer, D. Next, Thevenin's voltage is equal to the dash voltage across the dash terminals. Options are here. A is short circuit, comma input. B short circuit, comma output. C open circuit, comma output. D open circuit, comma input. Answer is C. Means Thevenin's voltage is equal to the open circuit voltage across the output terminals. Explanation: Thevenin's voltage is equal to the open circuit voltage across output terminals, not the short circuit voltage across output terminals. Next is numerical on Thevenin theorem. Consider the circuit shown below. The expression of Thevenin's voltage VTH is, by this diagram, options are A, V into Z1 upon Z1 plus Z2. B is V into Z2 upon Z1 plus Z2. C V into Z1. D equal to V into Z2. The correct answer is B. Explanation. Thevenin's theorem gives us a method for simplifying a given circuit. The Thevenin's voltage is VTH equal to V into Z2 upon Z1 plus Z2. This is the correct answer. B. Next problem. Determine the Thevenin's voltage across A, B terminals in the circuit shown below. This is the circuit. We have to find out the Thevenin's voltage across A, B. The options are A 41.86 angle 0 degree, B 42.86 angle 0 degree, C 43.86 angle 0 degree, D is 44.86 angle 0 degree. The correct answer is B. The explanation is here. The voltage across the points A and B is called Thevenin's equivalent voltage. Thevenin's equivalent voltage VAB equal to 100 angle 0 degree into J3 upon J3 plus J4. Finally, this is equal to 42.86 angle 0 degree volts. This is the answer B. Next question on Norton's theorem. Norton's current is equal to the current passing through the dash circuited dash terminals. Options are A short comma input, B short comma output, C open comma output, D open comma input. The correct answer is B. Explanation. Norton's current is equal to the current passing through short circuited output terminals, not the current through open circuited output terminals. So answer B is right. And again it is question. Norton's current is equal to the current passing through the short circuited output terminals. Okay. The next is the question on Norton theorem. The expression of Norton's current IN in the circuit shown below is, the circuit is shown here. Options are V upon Z1, B equal to V upon Z2, C is V into Z2 upon Z1 plus Z2, and D is V Z1 upon Z1 plus Z2. Answer is A correct. Explanation. The Norton's equivalent form of any complex impedance circuit consists of an equivalent current source and an equivalent impedance. The expression of Norton's current is IN equal to V upon Z1. Right? So answer A is correct. Next question on Norton's again. Determine Norton's equivalent current in the circuit shown below. This is the circuit. We have to find out Norton's equivalent current. So options are A 5 angle 53.13 degree, B 4 angle 53.13 degree, C 4 angle 53.13 degree, D 5 angle minus 53.13 degree. The correct answer is D, and explanation is that the current through the terminals A and B is the Norton's equivalent current. The Norton's equivalent current is I equal to 25 angle 0 degree upon 3 plus J4 equal to 5 angle minus 53.13 degree ampere. So this is the correct answer D. Next. Determine the Norton's impedance seen from the terminal AB. Terminal AB से हम देखते हैं when we view from terminal AB Norton's impedance. What is the Norton impedance? Options are A 6 angle 90 degree, B 7 angle 90 degree, C 6 angle minus 90 degree, D 7 angle minus 90 degree. The correct answer is C. Explanation is that The impedance between the points A and B with the source replaced by a short circuit is Norton's equivalent impedance. The Norton's impedance is ZAB equal to J3 into minus J2 upon J3 minus J2. This equal to 6 angle minus 90 degree ohms. This is Norton's impedance and correct answer is C. Next, the question based on maximum power theorems. The condition of maximum voltage to be transferred to the load is option A is source resistance greater than load resistance, B source resistance less than load resistance, C source resistance equal to the load resistance, and D source resistance greater than or equal to the load resistance. The correct answer is B. Explanation: our aim is to find the necessary conditions so that the power delivered by the source to the load is maximum. The condition for maximum voltage to be transferred to the load is source resistance less than load resistance. So answer B is correct. Next question also on maximum power transfer theorem. The question is the condition for maximum current to be transferred to the load is, options are A source resistance greater than or equal to load resistance, B source resistance equal to load resistance, C source resistance less than load resistance, D source resistance greater than load resistance. The correct answer is D. And explanation: the condition for maximum current to be transferred to the load is source resistance greater than load resistance. For many applications, an important consideration is the maximum power transferred to the load. So correct answer is D, source resistance greater than load resistance. Next question. In the circuit shown, determine the value of load resistance when the load resistance draws maximum power. This is the circuit. The voltage source is 50 volts, resistance is 25. We have to find out the load resistance for which the current is maximum transfer. The options are A 50, B 25, C 75, D 100. The correct answer is B. As we know, explanation is here. The source delivers maximum power when load resistance is equal to the source resistance. So load resistance will also be equal to the 25 ohms. This is the answer correct, B. Thanks.